Okay, hello. Here we are with section 5-4. This is the day 2 notes. Hopefully, by doing this lesson, some of what we did yesterday is going to start to gel a little bit better. Okay, so there's really 3 things that we have to be able to identify with direct variation. So we should be able to identify it from an equation. That's what the first part is going to be. We should be able to identify it from a table. That's what the second part is. And we should be able to identify it by looking at a graph. Okay, so in order to identify it from an equation, this is the important part over here, we're looking for the equation to be in the form y equals k times x. Okay, so if I write that below this, y equals k times x, is this equation in that form. Okay, so here I do have y, then I have k is replaced by some number, that's a constant, in this case it's 1.5, and then I have the x. So first of all, when it says tell whether it represents a direct variation, the answer to the first part is yes. Okay, the second part says identify the constant of variation, and the constant of variation is the value of k. So in this case, k is the 1.5. Okay. All right. So in the second one, again, if I were to write out the constant or the direct variation equation, it's y equals k times x. Is this in that form? I have y equals some number times x. So the answer to this one is yes. That is direct variation, and our constant of variation is 4. Okay, and the next one we have y equals 9x plus 0.5. So is this in the form y equals k times x? Well, we've got y equals, we have some number times x, but then we have this stuff right here. Okay, this part that's added on makes this not a direct variation equation because it goes beyond the k times x. Okay, the next one is 12y equals 3 times x. So with this one, we want it to look like y equals k times x. So we have to solve this for y. Okay, so when I solve an equation, I'm going to draw my dividing line. Okay, and I'm going to have to get rid of this 12 to get y by itself. So 12 is multiplied by y, so I'm going to divide by 12 on both sides. And I'm going to be left with y equals, and then again, I can always bring the fraction part out in front of the x. Instead of writing it as 3x over 12, we can write it as 3/12 x. Now, if you go into Desmos and you simplify this, it's y equals 1/4 x. 3/12 simplifies to 1/4. Okay? So is this in the y equals k times x form? The answer is yes, and our k value is going to be 1/4. So you always have to solve it for y to be able to determine what the constant of variation is. All right, so in this problem right here, I need to solve for y. Y is not by itself. So to do that, I would divide by 4, and I divide everything on that side by 4 as well. So when I do that, I'm left with y equals, and I can just leave this as x minus 12 all over 4. Now, is this in y equals kx form? The answer is no. Okay, there's all this kind of extra stuff being subtracted and whatever. Okay, then this one we have is 0.8y equals x. So again, I'm going to solve for y. I'm going to solve for y here by dividing by 0.8. All right, so that's going to be eliminated here. Now on the other side, okay, this is a little tricky because with this one, I just pulled the 3/12 out in front. And in this one, it's really a 1 in front of the x, so it's really like 1 over 0.8x. But we really don't want to have decimals in our fractions. So I am going to go into Desmos here, and I'm going to do 1 divided by 0.8. Okay, And we can leave it as a decimal. That's fine. It's 1.25. So I can write this as y equals 1.25x. We just don't ever want to leave decimals in as part of fractions. So the answer to this one is this in form y equals k times x? Yes. And our k value is 1.25. Okay, if you would have put it in fraction form, it's 5/4, and that would be acceptable also. All right, so that's how to tell whether an equation is a direct variation equation. I'm just going to give you a heads up. If you see numbers being added or subtracted, it cannot be a direct variation equation. So just by looking at the equation, I can kind of tell already that it's a no. Okay, so down here now we're going to take a look at whether we can tell from looking at a table. So to do that, my hint is over here on the side. Okay, what I have to do is try to find the k value by taking the y value and dividing by the x value for each value. Okay, so here, if I start, my first y divided by x is going to be -4/4, and that's a -1. Okay, the next y divided by x is this ordered pair, so I'm going to take the -1 and I'm going to divide by 8. -1 divided by 8, if you were to check this on Desmos, is -0.125. So already those are not the same number. So my answer is going to be no. I don't even have to check this third one. Okay, they need to be the same number. All right, so now here's another example. I'm going to be doing the y divided by the x. Now today you don't have to worry about this. It's going to be in the correct order, x and then y, okay? So we're going to be doing the y divided by the x first is 0.4 over 0.5. If you were to check that in Desmos, it's 0.8. Okay, now if I were to check 1.2, the next y divided by the next x, 1.5, guess what that is? 0.8. Okay, I'm just telling you what it is, but you can check this in Desmos. And then the last one, the y divided by the x, 2 divided by 2.5 is also going to be 0.8. Okay, so for this one, the answer is yes. Okay, and our k value is simply the number that we kept getting over and over and over. So in this case, it's 0.8. And then they also want us to write the direct variation equation. Okay, so up here, an example of a direct variation equation is y equals 1.5x. You just put the k value in there. So we're just going to write y equals, but now instead of k, I'm going to use our k, 0.8, and then the x, and that's my direct variation equation. Okay. All right, and this next one, again, I'm going to do the y divided by the x. So 1 divided by -1 is a -1. 2 divided by a -2 is equal to a -1. And 3 divided by a -3 is also a -1. Okay? So since I got the same number every time by doing y divided by x, the answer is yes. This is direct variation. Our k value is the number that we got when we divided y by x, which is -1. So therefore, the equation is going to be y equals -1x. Okay? All right. And this last one, we're going to do the same thing. And I'm just going to give you a heads up. Sometimes in the table, they might add the 0.00. Okay? And I'm going to talk about that along with this problem. So if I have 15 over 2, I'm going to do the 0, talk about the 0 last. So y divided by x, okay, I'm going to kind of do these down below here. 15 divided by 2 is equal to 7.5, 7.5. And then if I do 30 divided by 4, I also get 7.5. And if I do 45 divided by 6, That's actually also 7.5. Now, they also have 0, 0. And if you try to do 0 divided by 0, the universe is going to explode. That's undefined, right? But it's kind of just there to throw you off because by definition, a direct variation equation goes through the origin, right? That was one of the things we talked about yesterday. Does it pass through the origin? It has to. So if you ever see 0, 0 on a table of values, don't let it throw you off. If the rest of the values are all the same when you do y divided by x, the answer is yes. This is direct variation. Okay, our constant of variation is going to be 7.5. So that means y equals 7.5. X is the equation we can use for this table. So what that means is for every x value, if I plug that in here, I would get the y. So if I take 6 and I substitute it here, 7.5 times 6 would give me the 45. 7.5 times 4 would give me 30. 7.5 times 2 would give me 15. And do you know what? 7.5 times 0 is actually 0. So this one does work in our direct variation equation. Okay, the next one is how do we know just by looking at a graph? Okay, I think this is the easiest one. So again, we're going to ask ourselves two questions. Is the graph a line? And if so, does it pass through the origin? Okay, so if I look at this problem here, first of all, it is a line and it does pass through the origin. So yes, this is direct variation. Okay, the second part says, if so, identify the constant of variation and write the equation. So the constant of variation, this is very important, is that we use the slope for k. Okay, so the slope is the constant of variation. So we're going to count our rise over our run. It doesn't matter what points you pick. Since this is like really small on this graph, I'm actually going to start at the origin and count up and then over, I think. Okay. So with this one, I am going up 4. Oh, I don't really like this. This is hard to see. The line isn't very good here, you guys. Okay. So this actually doesn't meet on a nice, pretty dot. This actually, it's not quite at 2. It's not going to be at 2 till I'm here at 5. So I apologize for this. This one is really hard to see, this grid. It's going to be nicer on your PDFs, I promise. Okay. So your slope, in this case, sorry, I apologize. We're going actually up 5 and over 2. Okay, so that is our slope, which means that is going to be our k value, our constant of variation. And if that's our constant of variation, excuse me, the equation is going to be y equals 5/2 x. Okay, take a look at the next one here. Let's ask ourselves the two questions. Is it a line? The answer is yes. Does it pass through the origin? The answer is no. So this one is just no. This cannot be a direct variation. Okay, number 13, is this a line? Yes. Does it pass through the origin? Nope. So this one is no, not a direct variation. All right, and then this last one here, is it a line? Yes. Does it pass through the origin? Yes. So this one is direct variation. And we have to identify the slope to get the k, the constant of variation. So I'm going to go from 0, 0 to this point here. This one's a little bit easier to see. Okay, our rise and our run, we're actually going up 6 and over 1. So our k, our slope, is 6 over 1, and I could simplify that to just plain 6. So therefore, the equation is going to be y equals 6x. All right, today I didn't do any that are negative slopes, but it is possible to have a direct variation equation that's a line and it goes through the origin, but it's a negative slope. Okay, so don't let that throw you off if you see that. All right, let me know if you have any questions about this assignment now that we did day 2. Hopefully it's easier to understand.